Okay, year 10. So first of all, really well done on your work on yesterday's lesson. I know some of you found the exit ticket questions quite hard. So if that was you, please make sure you watch the exit ticket video first of all. But on the whole, I'm really, really impressed with how you're getting on. It's super important you're kind of continuing to stay really engaged and focused on your work. Right, for today, we're going to look at probability trees. I'm super excited about this. I'm reasonably confident that you won't have met probability trees before, but they're just like a really nice diagrammatic way, which should hopefully help to make some sense of more complex probability problems. So this here is going to be a probability tree. It's just we haven't filled it in with any information yet. So first of all, let's read the question. So Tina's got 2 bags of counters, fine. 5 red, 3 blue, bag A, 4 red, 5 blue, bag B. Fine, she takes a counter each bag. Now we've got to complete the tree diagram. With a probability tree, we always fill in our tree with fractions or decimals. We're always going to fill in with fractions or decimals. And here we are thinking, what is the probability of choosing a red counter from bag A? Well, in bag A, there are 8 counters, and 5 of them are red. And in bag B, in bag A still, sorry, there are 8 counters, and 3 of them are blue. So we filled in our first 2 probabilities. What's super important is that this and this add up to 1. 5/8 plus 3/8 equals 1. Then with bag B. So from bag B, the probability of choosing a red counter, well, there's 4 red, and there's 9 counters in total in bag B. And then from bag B, picking a blue is going to be 5 out of 9. Still from bag B, picking a red is going to be 4 out of 9. And picking a blue is going to be 5 out of 9. And then I'm going to add something here which is called outcomes. We're going to work out some outcomes now. So here we're going to work out the probability, I'm just going to write P for probability, of red and then red. So the probability of getting red and red, so when we've got to and red, we multiply. And so we would do 5/8 times 4/9. Which is 20/72. The next one, so this would be for the probability of red and then blue. So red and then blue would be 5/8 times 5/9, which would be 25/72. Then this here would be the probability of blue, then red, which would be blue, red, so 3/8 times 4/9, which is 12/72. And this at the bottom would be the probability of blue and then blue, which is 3/8 times 5/9, which is 15/72. Now, in terms of the kinds of questions you might get, we might get questions like this. So part A at the top says, what is the probability of picking a red counter and a blue counter? So red and blue. Well, there's 2 different ways that could happen, aren't there? I could either pick red and then blue, or blue and then red. They're both different ways of getting red and blue. So what I'm just going to do is add those 2 options together. 25/72 plus 12/72 gives me 37/72. Part B, sorry, I don't know where I got D from. For part B, what is the probability of picking 2 counters of the same colour? Well, there's 2 options for that again, aren't there? Because either I could pick red and then red, and that would be 2 of the same colour, or I could pick blue and then blue, and that would be 2 of the same colour. And so we add these options together. 20/72 plus 15/72 gives a final probability of 35/72. And then for part C, what is the probability of picking at least, let me just switch pens for the moment, of picking at least 1 red counter? Well, how could that happen? Well, I could pick red and then red, because that would be at least one red. I could pick red and then blue, because that would be at least one red. Or I could pick blue and then red, because that would be at least one red. I couldn't pick blue and then blue. So then all I do is I just take those probabilities, 20 over 72, plus 25 over 72, plus 12 over 72, and I add them all together, which gives me 57 over 72. And that's it. Okay, so second example, year 10. Hannah is going to play one game of chess, fine, and one game of backgammon. Sure. Right, the probability she'll win the game of chess is 0.6. The probability she'll win the game of backgammon is 0.7. So first of all, we'll start off with chess. The probability she wins is 0.6. And therefore, the probability she loses or does not win is 0.4. Because 0.6 plus 0.4 equals 1. Then moving on to backgammon, the probability she wins backgammon is 0.7. Therefore, the probability she does not win backgammon is 0.3, because 0.7 plus 0.3 equals 1, and then so on here. Now, after that, I'm going to add this outcomes row, just because this makes it a little bit easier when it comes to answering the questions you might get. So our outcomes, we could get the probability of win, then win. We could get the probability of win, not win. We could get the probability of not win, win. And finally, we could get the probability of not win, not win. So then let's just write out our probabilities. So in terms of that then, win and then win is 0.6 times 0.7, which is 0.40. Win is 0.6 times by not win is 0.3, 0.18. Not win is 0.4 times win, which is 0.7, which gives us 0.28. Oh, sorry. Just erase that bit. And then finally at the bottom, not win. Oh, not such pens yet. Not win is 0.4. Not win again is 0.3, giving me 0.12. Now we can use all of that to help us answer some questions. For example, what is the probability that Hannah wins one game and loses another game? So how many different ways could that happen? Well, this way that could happen, because she could win and then not win, or she could not win and then win. They're both options. So all we do is we take both options and add them together, and when I add those together I get 0.46, which is my final answer. For part B, what is the probability she wins at least one game? So that at least one is super important language here, year 10. So she could win and then win, she could win and then not win, or she could not win and then win. All of those three are valid options. So then we just take those three probabilities, 0.42 plus 0.18 plus 0.28, and we add all of those together. When we do that, we get 0.6, 0.88, and that's it. That is our final answer. Okay, so by now year 10, you should hopefully be able to have a go at all of the questions from the task. They start hopefully quite straightforward and build up to being a bit more difficult. As ever, if you get stuck, it's really useful if you can maybe take a photo of some of the work you've tried, just so I can see if you're on the right track and give you some guidance based around that. Good luck. No exit ticket questions for today. And then tomorrow you'll be doing like some review work based on all of the probability stuff we've done so far. Good luck, and let me know if you need any help.